Welcome to our channel. Today here I am with the second lecture on the subject surveying for JLEE, NEE-3, CITLEET, APSC and all other competitive exams. Here also I have discussed some of the important topics and some important MCQs which I have collected from some previous year's question papers. Today's first topic is types of chains. So we have different types of chains used in surveying. So the first one is our metric chain. Then again, metric chain is of two types. One is 20-meter chain and the other one is 30-meter chain, which we have used in our labs. Now, first the 20-meter chain. In 20-meter chain, we have 100 links. Then each link is of 0.2 meter and tallies are provided at every 10 links. So if one link is 0.2 meters, so 10 link will be our 2 meter. So I have discussed only the main important topics. And then we have the 30-meter chain. In 30-meter chain, we have 150 links. Each link is of 0.2 meter. Tallies are provided at every 25 links, that is 5 meters. So if one link is 0.2 meters, so 25 links will be 25 into 0.2, that is 5 meter. Then second type of chain is our steel band. So the steel band consists of a ribbon of steel of width 16 mm and length 20 or 30 meter. This chain is graduated in meter, decimeter and centimeter on one side, and on the other side it has 0.2 meter links. Then the third type of chain is our engineer's chain. So this chain is 100 feet long. It has 100 links. Each link is of 1 feet. Tallies are provided at every 10 links. That means if one link is of 1 feet, so 10 link will be 10 into 1, that is our 10 feet. Then number 4 we have Gunter's chain. So in Gunter's chain, the length is 66 feet and we have 100 links. Each link is of 0.66 feet. Then the last one is our revenue chain. It is 33 feet long and it is divided into 16 links. This revenue chain is used in cadastral survey. Now let's see one question from a previous year paper. Tallies at every 20-meter metric chain at every, that means tallies are provided in a 20-meter metric chain at every 1 meter interval, 2 meter interval, 3 meter interval, 4 meter interval. So for a 20-meter chain, our tallies are provided at every 2 meter interval, that is our option B. So this is our answer, option B. The next topic we have correction. First we have tape correction. Now under tape correction, our first type of correction is temperature correction, which is denoted by CT. So the formula is CT equal to alpha Tm minus T0. Now let's see what each denote. CT is our temperature correction. Then our alpha is the coefficient of thermal expansion. Tm is temperature during measurement in degrees centigrade or Celsius. And T0 is temperature at which the tape was standardized in degrees centigrade or Celsius, and L is length of tape in meters. So I forgot to write, here will be our one L, it is capital L, that will be the length of tape. So this is the formula for temperature correction. You can note down the important points. Now here we have some conditions. If Tm is greater than T0, that is if the temperature during the measurement it is greater than the temperature at which the tape was standardized, then our correction is positive and then the error is negative. Always remember one thing, that always if the correction is positive, error is negative, and if correction is negative, the error is always positive. And vice versa, that is if Tm is less than T0, then correction is negative and the error will be positive. The second type of correction is pool correction, which is denoted by Cp. So the formula is Cp equal to Pm minus P0 into L divided by A into E. Now here Cp is our pool correction, then Pm is pool during measurement. P0 is our pool at which the tape was standardized, L is length of the tape, A is cross-sectional area of the tape, and E is Young's modulus of elasticity. Now here also if Pm is greater than P0, that is if the pool during measurement it is greater than the pool at which the tape was standardized, the correction is positive, so the error will be negative. Similarly, if Pm is less than P0, the correction is negative and the error will be positive. Then the third type of correction is our slope correction, which is denoted by CH. So CH is h square by twice L, and the slope correction is always negative. So the important point for slope correction is that it is always negative. Next, fourth type of correction is our sec correction, which is denoted by CS. So CS is WL square by 24 N square by PM square. Here CS is our sec correction, L is length of the tape or chain. Then we have capital W, which is total weight of tape. So total weight of tape is equal to small w into L. This L is the length and small w is weight of tape per unit length. Then this is 24. Then N is our number of spans and PM is pull during measurement. And this sec correction is also always negative. So the important point for sec correction is that it is always negative. Now let's see a question. Here it is asked that sec correction is always negative, always positive, sometimes positive and sometimes negative, and 0. So our answer will be always negative. That is our option number A, always negative. The next question, the error in measured length due to sag of chain or tape is known as positive error, negative error, compensating error, instrument error. Now how to get this? Now we know that sag correction is always negative. So if the correction is negative, our error will be positive. So our option will be option A, positive error. Next we have chain correction. So under chain correction, the first is correction applied due to incorrect length. Now suppose after measurement we have taken an incorrect length. So what will be the actual length which we have to apply? We have to see that, because sometimes due to some errors, maybe personal error, maybe human error, maybe instrumental error, we have different errors. Due to some of the errors we may not get the actual length. There may be some error. Then how to calculate the true length or the actual length? So true length denoted by TL, this is equal to L dash by L into ML. Now what are all these? Now ML is our measured length. Then this L, capital L, this is the standard or true length of chain. That means this capital L is our actual length of the chain. And L dash, L dash is our true length plus minus error. That means after the error, that means the incorrect length which we got, it may be greater than the original length plus error, or it may be less than the original length, that is minus error. So now when to use positive and when to use this negative sign? So we use the positive sign when the chain or tape is too long, and we use negative sign when it is too short. Just remember this. Then second type of correction is correction of incorrect area. So true, that means if the area is wrong, so how we'll get the true area? This is L dash by L whole square into measured area. Now this, you know, measured area, we know L is the actual length of the chain and this L dash is the actual length plus minus error. So we know that length square is our always area. That's why we have done this. And third one is hypotenuse allowance. So hypotenuse allowance per tape equal to L sec theta minus 1, and this hypotenuse allowance, it is always added to the length of the tape. So here this capital L is our length of tape and theta is slope of the ground. This is not so important, just you need to remember the formula, and this point is required, always added to the tape length, this hypotenuse allowance. Now let's see a question. It is given a 30-meter chain is found to be 0.1 meter too short throughout the measurement. If the distance measured is recorded as 300 meter, then the actual distance will be. These are the four options, and the options are very close to each other. Now what is given? See, 30-meter chain. That means 30-meter chain means our length of the chain, that is capital L, will be 30 meter. It is found to be 0.1 meter too short. That is 0.1 meter is our error, and it is given too short. So too short means, for short we always use the negative sign. So how we will get the L dash? L dash is our L plus minus error. So L is our 30 and we are using the minus sign before the error. Why? Because it is too short given. So we have got L dash as 29.9 meter. Then say what is given. If the distance measured is recorded as 300 meter, that means this is our measured length 300 meter ml. Then the actual distance, that means the true length you are asked to find out. Now see here, ml is given as 300 meter. Now the formula for true length is L dash by L into ml. So putting all the values will get the true length as 299 meter. So that is our option C. That is 299.00. I'll show you. See, this is the option C, 299.00 meter. This is our answer. If you have any doubt, refer to the mail ID given in the link below. You can also refer to our Facebook page, Instagram page. Link is provided in the description box. So this is the end of today's session. Thank you very much for watching the video. If you like the video, do like, comment, share and subscribe to our channel for further notifications.